Yeah, so guys, now today we have yet another Himel. This Himel is not near my videos. I'll be doing this same video, I think the third time. But each video it has got more details or different information. Yeah, I've done several of this. Yeah, you can see so closely. And actually this one is the manual book. Yeah. So you can see the face from the face of my panel. This is a 7.5 kilowatt VFDs, two of them in one panel. Yeah, this panel is 700 by 500 by 200. Or if you want in centimeters, it is 70 by 50 by 20 centimeters. Yeah, actually I had designed this panel for a 4 kilowatt two 4 kilowatt VFDs, which I am yet to do them, but unfortunately we changed, and that's why they are a bit squeezed there. I tried to squeeze as much as possible. They have fit, it has fit so, but the space is not that big, the remaining space. So I would rather go for 800 by 800 by 200. Yeah, for this 7, or even I can go, let's say 800. Yeah, I'll go for 800 600 800 600 200 for the 7.5 kilowatt. Yeah, that space will be sufficient enough. Yeah, unlike this one, it's a little bit small. Yeah, so I will give you the part number of this the part numbers are here, although inverted. Yeah, inverted. Yeah, so let me try. You can see, right? So this is the part number of this VFD. HVA SP 4000775P. Yeah, and we have a 4 kilowatt VFD. They are here. Yeah. So you can see also this ones, they have their part number HVBA 40040G is 4 kilowatt. It's a little bit small, though there's a little difference between 7.5 and this one here. The 7.5 is coming up to somewhere here, and a little bit more. Yeah, but this one they were fitting in that panel so well. But for this 4 kilowatt, I'll fix it in this panel. The panel is ready. This one is 400 by 500 by 200. 400 500 200. Yeah, this is the size of this you can see it can fit very well one VFD. This VFD is Schneider, but this one can as well fit inside here. Those ones, the small, that smaller one can as well fit, although it is a little bit long. Let me see, it's a little bit long, but yeah, it will just fit. Yeah, it's a little bit long, but it will fit. Yeah, so So the next thing, I will show you how to go up to the program of this VFD. And the most important programs here, which we had earlier discussed, some of which we had earlier discussed here. I think you can focus here. You can focus on those the parameters that we are supposed to set. You can see there is f1.01, f1.02, f1.03, f1.07, f6.01, f6.13, f6.37, f3.01, f3.02, f3.03, f3.04, and f3.05. Those are the parameters, the most important parameters. So as we go through them, I will try and explain further. So we go F1s, go inside F1. F1, we start with the F1.01. Yes, F1.01, you can see it is about let me focus, setting F1.01. F1.01 is channel of running command. We select number 1. The default is 0, but we select number 1, which is the terminus actually. Number 1 is running from the terminus. We shall connect our cables from the terminus. Then we go to F1.02. F1.02, setting channel of main frequency X command. We put digital input 1, select number 1. The default is 0. Then we go 1.03. In this case, we have 0 to 10 volts. You see, I've fixed my battery there, the 9 volts battery. We shall apply 0.0 to 10 volts AC. So that's why we go to F1.03. and we select analog input 1, which is number 4. Initially it was 1. Okay, then what is our next thing? Our next thing, we have F1.07. In this case, this is where we shall set our preset speed. We have our preset speed when it comes to the hand side. The hand side, which is this side, HOA, hand off auto. Hand side, we have set 45 Hertz here. And this 45 Hertz we set at F1. I can show you from here. This one is already running. You can see indicated forward is running. This one is not running. So I can comfortably show you from this one. F1.07. See, that's where I have set my 45 Hertz. You can change. Let's say put 43. And we exit. So this other one, which is number 2 here, we run up to 43. That's what I have set. So that's where you go to F1.07 and you set that speed That is in as per frequency X, which is you get from digital input 1. Then we go from there f1.07, then we go f6, f3. We have got f3.01, f3 up to f3.05. Yeah, as you can see, f3.01 is the rated power, and our power here. So I can switch this one off, then we can go through it. I'll switch this one off. Our lamp will stop the moment the frequency has come to 0. So we have gone up here. So here I have to go f3, f3.001. The rated power, yeah, it's 7.5 kilowatt. It's already set here. Then we go f3.02, the rated current, yeah. We exit. The rated current is 15 amps. Yeah, but that one we shall read from the nameplate of the motor at site. We don't have the motor with us here. So then we go f3.03. That's the RPM, revolution per minute. The RPM. We don't have it. This one we shall get from the nameplate. Everything here we shall get from the nameplate. And that one is the frequency, which we shall get from the nameplate, of which it will match. I think it will match with the frequency here in UAE, which is 50 Hertz, yeah? So, exit, go there, and that is a voltage, yeah? Of which I believe it is. We shall set 400. The voltage here is 400. And I believe the nameplate is also 400, 400 volts, yeah. So, once we are done with that, then we shall explain some other things here. So we are done with these programs, those parameters, and we go for f6.01. f6.01 initially default it is 2, which is not showing it's a reverse. So f6.01 we select 32, and what is 32? Let's go inside and see. f6.01 you see the default there is a reverse, it is 2, but in this case we want to set 32. 32, what is 32 indicating there? Is the frequency source switch to auxiliary wire. Okay, that is not very important because already we are not using frequency Y, it's only frequency X, yeah? So, then we go for f6.13 and f6.37. These are for the relays. The other VFDs, the one I've already taken the videos from my videos, they don't have two relays, internal relays. But in this case, this one has got 2 internal relays, RA, RB, RC, and TA, TB, and TC. So, between TA and TB is normally closed, and between RA and RB is normally closed. But between TA and TC is normally open, and between RA and RC is normally open. So, I have chosen to, you can make either of them for the fault and the other one for the run. So in this case I've chosen TAs, TB and TC for my fault, yeah, which is the relay which is down there. So I've taken between TA and TC, and I energize my trip relay. And energize my trip relay. So in case there is a fault, this one will trigger and it will energize that relay number number 3, which is my trip relay. Actually, my first relay is the hand relay. You can see H there. That one is the one which is energized when I select hand. Yeah, when I select hand, you see, now I switch off. Yeah, when I switch off, on, it will energize that part relay. And actually, the second relay, when I loop here command, which is 3-4, that is the time the second relay is triggered. Yeah, the second relay will be triggered. Yeah, and the number 3 relay is the trip relay, and the number 4, I'll call it operations relay. This is the one which is energized by this relay, which is RA and RC. RA and RC, you can see there my number 20 is energized for the relay, which will indicate the lamps. It will indicate the VFD is running to the BMS. It will give the BMS it's running, and at the same time it will run this fan. Now you see, this fan will be energized through this relay or this relay, this other relay. My last relay here is the fire alarm relay, which will switch off the 2 VFDs just in case there is a fire alarm. So F6.13 default is 17, which is a fault. Yeah, that one I keep it as it is. But I go to F6.37, I select one which is default. Before it was 0 default, it was no function, but I make it 2. I select 1 to make it a run relay. Yeah, and that's all. Actually, then I have my 0 to 10, 11 I feed it to analog input 1. You can see there, analog input 1. 12 I feed it to ground, and 13 analog output 1. 13 is analog output 1, which is down here. Yeah. And actually my wiring, which I've indicated in a certain paper here, my wiring for relay number 2, which is relay number 2, which is for outdoor, is between ground, digital input 1 and digital input 2. The second relay. Yeah, and it will run when there is between analog input 1 and ground, when there is 0 to 10 volts. Yeah, it will run, and analog input 1, it will give the speed feedback. And if it is hand only, running hand, is between ground and digital input 1. And the frequency preset speed I'll do at f1.07, which is, you can see, it is one cable here, relay 1, and this relay 2 has 2 cables because it is going between digital input 1 and digital input 2. Actually, there isn't much. It's a very simple. It has a very simple concept. And as you can see, I've already looped 3-4, which is the command for running, and I have fed my 0 to 10 volts. So I expect it, which is around 8 volts, 7 point something volts. You can see almost 8 volts here. Because per volt, we expect 5 hertz. And this other one cannot run auto because there's no command between 3 and 4, and there's no 0 to 10. It can only run on hand the preset speed at f1.07. Okay, that's enough for today, guys. So see you next time. Okay, bye.